Alright, limiting reactants is what this video is going to be on today. So a limiting reactant problem it's based around the idea that unlike the stoichiometry problems we have been doing where you'll be given like an excess amount of oxygen or excess amount of propane, where essentially you have more than enough of one of your reactants. And here we're going to be given two more finite amounts of both reactants. As we can see in example 1, we're given 50 grams of hydrogen and 39 grams of nitrogen. And so what we'll end up having to do basically is two stoichiometry problems with using both of the different givens to solve for the same unknown. And once we get our actual answers, I'll come back to these bullet points. So I already got the balanced equation. That should be mostly review. Nitrogen is diatomic, hydrogen as well, nitrogen trihydride, NH3. And so we start with 50 grams of hydrogen gas. So that is one of our givens. And 39 grams of nitrogen gas. So two givens here, 50 grams of H2, 39 grams of N2. Our unknown, we're going to find our unknown in part A. It says what mass of ammonia, which is NH3, can be produced, mass being measured in grams. So our unknown is grams of NH3. And so we're going to insert two 5x2 tables. So I'll just copy and paste this first one. And we'll use one for each of our givens. And so with each of these, we're going to go through our stoichiometry process, which is why I've got our flowchart, notes with the flowchart up here on the top right of your screen. So we have that to kind of guide us along. So our first step is to get our given into moles. So we have grams of H2. I bring that down. We need to get that to moles of H2. Anytime our units are different, moles and grams, remember we're using our conversion factor here. So that's 1 mole. And the molar mass in grams, hydrogen's got a mass of 1, so H2 is 2 grams. So that takes care of the first step of our flowchart. Next, we need to go from moles of our given, so I'll put that on the bottom, convert it to moles of our unknown. So moles, our unknown is NH3, so NH3, moles of NH3 on top. Now moles over moles, this is the step where we're going to get our numbers from the balanced equation. So NH3 which I got highlighted in that light purple, has a coefficient of 2. H2 in our balanced equation has a coefficient of 3. So that's where our numbers are coming from the moles over moles step. So that takes care of this this middle step of our flowchart. Lastly, we need to convert our moles of our unknown, so moles of NH3 on the bottom, into the unit the problem asks for. So here that is grams of NH3. And so with grams and moles, basically not moles over moles, we're back to using this conversion factor, which means for moles it's just 1 again. We are going to need the molar mass of NH3. Nitrogen is 14. Already said hydrogen is 1. There's 3 of them in NH3. So that's 17 grams. And so that's our stoichiometry setup. And so now we'll plug that in the calculator. Since we have 2 both on top and bottom, we can just cancel those out. We don't need to type them both in. If you type them both in, you'll get the same thing. So not a huge deal. We'll get 283.3 grams of NH3 for our first table. And so now we're going to redo the process, which is going to be similar in a lot of ways, but for our nitrogen given. So again, we'll bring our grams of N2 down. And again, first step, convert our given into moles. So that means moles, this time of N2, not H2 on top. Using this conversion factor to get our numbers. So 1 mole, molar mass of nitrogen is 28, since 2 N2s. Next step is to convert moles of our given, so I'll put that in the bottom, into moles of unknown. So here it'll start to look similar to our top table, with moles of NH3 on top. Moles over moles, remember that is using the coefficients. So that means 2 again for NH3. N2 on the other hand, there's no coefficient on N2, so that's an understood 1. And then the last step of stoichiometry is to convert our moles over unknown, so that's moles of NH3 on the bottom, into the unit the problem asks for, which is the same unknown as the first one, grams of NH3. And so this last step is going to look exactly the same for both of them. And so now we'll plug that into the calculator. So we get 47.4 grams of NH3. And so now if we look at these bullet points, of our 2 unknowns we convert to, the lower of the 2 is our numerical answer. So this guy, the 47.4, is going to be our answer. The lower amount is the amount that can actually be formed. Like if you're doing some cooking, if you're making a grilled cheese, if you have 1 slice of cheese and a whole loaf of bread, all you can make is 1 grilled cheese because you're limited by that 1 slice of cheese. So here we're limited by our amount of nitrogen, which leads to this next bullet point. Our limiting reactant is the starting substance that leads to the lower of the 2 stoichiometric answers. So 47.4 is our lower answer from stoichiometry. We look back at the start, and N2 is what got us to that lower answer, so that is our limiting reactant. As opposed to the excess reactant, which is again a starting substance, but it leads to the higher of our 2 stoichiometric answers. So 283.3 was our higher one. We look at the start of that, and it was hydrogen that led us there. And so that is solving a limiting reactant problem. Hopefully you'll be able to find that of help, and I'll see you for the next video.